Hello. In this tutorial, we're going to learn about functions in Dart. In Dart, to create a function, you just need to name the name of the function. I'll call this function new function. And there we have it. That's our function. You don't really need to specify a return type. So I'll call this function in our main function. And there you have it. If I run the program, it prints hey. So what happens is that main calls new function. New function runs its code, and its code is print hey. Now, you're advised to specify the return type of a function. Now, the return type of this function is void because it actually doesn't return anything. I could have a return type of int, string, or even boolean values. Now, if we specify a return type and return a value that is not in line with what your return type is, you're going to have an issue. So let me explain what I just said. We all know that if you have programmed in other languages, that when you specify a return type, it has to be the same return type you're actually returning. Like here, I'm returning 0. And I specified a return type of string. 0 here is an integer. That will give me an error. I have to change this to a string for it to work. So also, if I specify an integer and I'm returning a string, it gives me an error. But if I remove that type and just make it just the function name without specifying the return type, it will infer it's just like using var. So here I'm returning lovely. If I want to print out what is returning, I can assign what you return to a variable in the main function. I'll call that return value. And then I'll print return value. Now that is lovely. Isn't that lovely? Lovely. Now I can have another function. I call it calc age. Now this function is meant to calculate your age based on this year 2018. So it will get your age, subtract it from 2018 and return how old you are meant to be. So now once it gets the age, it prints the years you are. So let's say there's a person born in year 2000. What it does is subtracts 2000 from 2018 and prints the year. So he or she is 18 years old. So this is how you use arguments in Dart. You can have multiple arguments. You can have name and the age. So I can add a name and call it Daniel. And the year he was born. So I can have, hey, Daniel, you are 18 years old. But I can do this operation instead of printing the string there. I can do the whole generation of the string in the method. So I can say, hey, Daniel, you are. And remember how to perform expressions in string using the $sign. So here in the main function, I'll call that variable message. And I get the message from calc age. That is the message that calc age is returning. Now calc age takes the name, the year. Then it generates the string, gets the name and say you are 2018 minus the year. Now that is an expression I taught you how to do earlier in that, using a $sign and then curly brackets around it. So I print this message and it should say, Daniel, you are 18 years old. Yeah. So that's what it's meant to do. And it does that. So now we're going to add a third variable, call it height. Now this height is supposed to get the height of the person. And we'll use that value. So I call it, let's say Daniel is a tall guy. He's 6.0 feet. 6 foot. Now, what if sometimes I don't want to use this argument height? We can make it an optional argument. So to make something an optional parameter, what we do is that we surround it between square brackets. So we put double height between square brackets. That makes it optional. So when we remove that 6.0 value, you can just put the name and the year he was born. I wouldn't get any error because it says, okay, hey, I need the age, I need the year. You didn't give me the height, but I'm fine with it because I know it's optional. So whether you put it or not, you don't get an error. But you must make up for it in the function. You do a code to check if height was given. So if the user provided the height, you should give them a different string, a different message than if he or she did not provide the height. So if the height was provided, or if the height was not provided, you can just say you are 18 years old. But if the height was provided, you can say you're 18 years old and you are 5.6 foot tall. So I guess that is quite clear. So you have anonymous functions. Now, anonymous functions in that are nameless functions. Now, you can assign an anonymous function to a variable so that you can do things in a list, in a collection. Now, anonymous functions look similar to named functions because anonymous functions, they don't have names. Now, anonymous functions can have 0 or more parameters and like other functions separated by comma, and they mustn't have type annotations. So now I have a list of cars: Lamborghini, Ferrari, and Bugatti. Yeah. Actually, before I entered computer science, I was thinking of automobile engineering. I really liked cars. I really studied about cars. But anyhow, I went to programming. So now let's create. Now we have our for each loop. In this for each loop, we will put an anonymous function inside. So our anonymous function, like normal functions, has these parameters. But the parameter here will just take one item. I'll call that parameter item. You can call it whatever you want. So now, what should I do to this item? Now, as it is looping through cars, it's getting each item from the list cars. So what I want to do is to print each item. So it should print Lamborghini, Ferrari, and Bugatti. So now that's what it's meant to do. So that is what it did. It's quite straightforward. So we can also assign this anonymous function to a variable such that we can now use that variable in the for each loop instead of the whole anonymous function. So let's call this variable print cars. And now we assign it this anonymous function. So now, this is quite a nice feature. So now we can use this variable print cars in the for each loop. So imagine if this anonymous function had a lot of code. All you need to do is assign it this variable and then you can use it in the for each and it does the same work. It's a truly object-oriented programming language. Truly object-oriented. So here we're going to talk about lexical scope. Lexical scope. So now lexical scoping, it's known as static scoping also. So what happens is that when a variable is defined, it is only possible to call that variable within the block of code which is defined. So that is, there are some areas where you cannot access that block of code. So let's use this example. I'll have functions and variables. I'll have level 1, level 2, level 3. So now I have a method level 2 and level 3 in addition to main. Now, main has a variable level 1, main level 2 has a variable level 2, main level 3 has a variable level 3. So now this is how it happens. Level 3 can access level 3, level 2, and level 1. So this main level 3 can access the variable level 3, level 2, level 1. Let's give them some values. So I can print level 1, level 2, and level 3, as you can see. And that is from main level 3. In main level 2, I can't access the variable level 3, but I can access level 2 and level 1. And from the main function, I can only access level 1. I can't access level 2 or level 3. So those are kind of like this is what lexical scoping is about actually. It just means that the scope of the variables is determined statically simply by the layout of the code. You follow the curly brackets outwards to see if the variable is in scope. So here, that's what it's about. And for the main function, you can just access level 1. If you want to access another variable, let's say a global variable outside the main function, you can now access that. Perhaps let's say we wanted to name a variable outside this main function. Probably would we call it maybe level 0? Level 0, yes. So now main function will be able to access this and every other function inside main. But these are the only two variables main function can access, while main level 2 can access 1, 2, that is level 0, level 1, level 2. While main level 3, which is inside main level 2, can access all the variables outside it. But the functions, the methods, the functions outside cannot access the variables in the functions inside them. So main level 3 is inside main level 2. Main level 2 cannot access level 3 variable. So now, next, what we have here, we're going to talk about functions as objects. I've been talking a little bit fast. So we're going to talk about functions as objects. So you can assign a function to a variable, very similar to what we did with anonymous function, but the way you use it in for each loop is a little bit different. So let's say we have a variable that we have a function with a parameter name, and then all we do is to print out that name. Now we want to use this in a for each loop. So we have a string of names, a list. So we have one variable names, and we create a list, create different names now. Name the names. We have Daniel, David, and the likes. And we want to use a for each loop. So yeah, we have 4 names now. So we create a for each loop. And for us to use a for each loop, we just put the name of the function inside the for each loop. So we just do names dot for each and put in say hello. Hello, say hello. Now that's all we need to do. Put our semicolon, and when we run the program, it prints Daniel, David, Lemuel, and John. That's it. So now we can assign this function to a variable, because that treats functions like variables also. So what we can do is we get a variable and assign this function to it, and then we can use that variable in our for each loop, just as how we use this say hello function right now. So we create a variable. We call that variable say hello object. Say hello variable. Yeah, you can call it that. And then assign the method to it. Because here methods are like objects also. Because this is object oriented programming. By the way, I'm going to be doing an object oriented programming tutorial very soon. So for in case you are yet to fully understand it, or anyone you think doesn't understand it, I'm going to be doing one very soon. So now we can use that variable, say hello variable here, just like how we use the method. So you can assign this method to different variables and use them as you wish. So that is it, using methods as objects here. You can really do a lot in that. That is a really modern language, and you can see a little bit of Python, Swift, different modern languages. So now here we have lexical closures. Now, when it comes to lexical closures, I need to explain very well. A lexical closure, you can call it closure or function closure. Now, it's how would I put it? A closure is like a record storing function. So you could have a function now. Now, this function, I'll call it add more. It returns a function. Yes, it returns a function. So now, a lexical closure is a function object that has access to its variable in its lexical scope, even when the function is used outside of its original scope. Yeah, that may sound funny, but so here's the thing. You have this, it returns a function that adds initial number to I. Now, the function remembers what your initial number is. So let's demonstrate this very simply. So now we'll have two different examples to show you the different environments. So our first variable, we'll call this variable add5, and the second variable is add7. So now in the first variable, I put the argument 5 and the second one argument 7. Now, if you look at what goes on, 5 is said to be the initial number for add5, while 7 is the initial number for add7. Now, if I go on to say add5 and I put 6, and I say add7 and I put 3, what happens? Does it actually print 6 and 3? No, it prints 11 and 10. It adds 6 to 5 and it adds 3 to 7. Now, that is how lexical closures are. It remembers, okay, yeah, your initial number was 5. So it carries that, it has access to the variable, even though it's not used in its lexical scope. Now, it still has access to the initial number. So when I added 6, it went on to add 6, which will be the I now. 5, I'll call that the initial number. Why 6 is the I? Because it returned a function that adds I to the initial number. Now, time for Q&A. Very fast, huh? So, now that I just taught you that, what would be the answer of this? So here's the answer now. The first variable is called times 10 and the second one is times 4. And what I'm returning is initial number times I. So you get the initial number, hold it, and return a function that multiplies the parameter I times the initial number. So here we have initial number 10 and the second one is initial number 4. And then the next, when I'm using the variables, I say times 6. Like I put 6 as the argument and the second one 3. So it's meant to be 6 times 10 and 3 times 4 when I run it. So you can read more on lexical, that is 60 and 12. You can read more on lexical closures because this is a lexical closure example. You can read more of it in case you get a little bit confused about how it works. But basically, I'm sure you have a rough idea of how everything works. So my next question is, let's say I have a function with two parameters, name and address. So I have, hey name, let's say your name is Bob. Hey Bob, you stay at Washington. And then I want to print out this string. Yeah, so Lemuel stays on Earth. But let's say I want to make address optional, right? So I decided to remove Earth, and my program gives me an error. So how do I make it optional? Now you tell me. So in order to make it optional, like I told you, you surround the variable, the parameter, by square brackets, and that makes it optional. So you see no error no more. So now I can just put Lemuel, and then I'll have to edit my code to work with that update, so that I check if an address was given. If address was not given, then I give a different message. If an address was given, I give a different message. If there was no address, I just say hello Lemuel. If there was an address given, I say hello Lemuel, you stay out. So I think that should be clear to you by now. And we could even return the string instead of printing it here. We could return it and call the variable message. And in the main function, no, this is not what I've answered the question. I'm just adding extra here, so we can print the message here. That is returning a string. If you notice, I didn't put any return type on the function register. It already knows that, yeah, this is a string. If I decide to put int, then you have an error. So, oh, I missed a bracket there. Hello Lemuel. Yeah, thank you.